Hi, my name is Duncan McFarlane. With my colleague Greg Hawkridge, we're going to talk to you about low-cost digital solutions for small manufacturers, what we call the shoestring approach. We're going to give you a quick overview of this project that we've been working on, the shoestring project. I'll give you some examples of the type of low-cost solutions we've developed, and then Greg is going to take you through the design approach we've been developing. So the project itself began as a concept back in the 80s when I was a student travelling, and I travelled with Europe on a shoestring guide that Lonely Planet put out, and it was all about how to do things as cheaply as possible but still get enjoyment out of your travelling. So with that in mind, when we start to look at some of the challenges that SMEs and other manufacturers were facing in trying to develop digital solutions 3 or 4 years ago, we decided to take this, what we called a low-cost tactical approach to digital manufacturing, where we try to develop individual solutions, digital solutions, for which the total cost of deployment was kept low. And one of the other things we were really focusing on was trying to make use of the fact that lots of low-cost devices and technologies were becoming available in the non-industrial space, so how could we make use of them? So the vision for the shoestring project is what you see there. How do we increase digital capabilities in manufacturing through low-cost but easily accessible off-the-shelf components? So the basic vision for the approach, and Greg will go into more detail, is that we take these off-the-shelf technologies, embed them in what we call building blocks, and that's because those technologies are not necessarily industry ready. So we embed them in a building block which would make them into industry ready, and then actually combine those building blocks in standard manners such that we can reuse those combinations and ultimately make solutions such as part tracking or monitoring or job scheduling, the sort of simple day-to-day digital solutions that companies would like to have but perhaps don't have at the moment and can't afford. The project itself has a large range of partners and an even larger range of companies we work with, and the partners come in 3 categories. You might predict that we have solution providers, you might also predict we have small manufacturers involved, and actually a larger number than you see listed there. But also we have industry associations, and the reason for that is there's over 100,000 small manufacturers in the UK, so our best way to reach them is through the associations we work with them. So now I'm just going to give you 3 examples of the type of solutions we've been developing using the design method that Greg will take you through. Firstly, we developed a simple inventory tracking system using a low-cost camera, some very low-cost microprocessor, and free software. And the whole idea is that we'd scan parts under a camera, then we'd have a system that would recommend where to put those parts. We also have a searchable mechanism, and actually in later development we've allowed the system to actually provide suggestions where similar parts can be detected for an item. So that's an inventory tracking solution. Another solution, another quick, simple solution put together in 3 or 4 days was an augmented reality equipment status monitor, which would enable easy access to allow us to visualise where parts, the status of parts or equipment on the shop floor. And could be essentially added to any piece of equipment, and in fact the system now running on a camera or a tablet with shareware software would automatically discover any available augmented reality source in the environment. And thirdly, something we've been developing over the last year is a way of extracting data from legacy panels, control panels or display panels in a manufacturing environment. So it might be things like knobs or dials or analog displays that have no digital connection themselves. We actually digitize or network their display or their information through a camera-based system which looks at the display and will turn it into a digital signal. So potentially we also, that sort of signal can be connected up to the manufacturing process. So one other point, we've done this for 14, 15 or other different solution developments using our design approach, which I'll now hand over to Greg to get him to take you through.
Thank you, Duncan. I will now go through the shoestring design process. So in the slide you can see an overview of the entire approach end to end. It's mainly got 2 phases, the design phase and then the build and use phase. In the design phase, we have digital manufacturing needs assessment, solution specification and development. Then onto the build phase, we have procurement, installation and testing, training, and then operation and maintenance. But in this morning's presentation, we'll be focusing on these first two in the next few slides. So, the digital manufacturing needs assessment. It has 4 main phases, starting with shortlisting, then onto prioritization, then features, and then specifications. So when it comes to digital manufacturing, there's a lot that can be done. And this can be quite daunting for many SMEs who don't really know where to start. So the way that we address this is that we have a catalogue of approximately 50 digital needs that can be addressed by low-cost digital manufacturing solutions. And the way that we go through the shortlisting process is the company looks through this catalogue and they identify a set of, say, 5, essentially their shortlist of digital solutions that they feel would be sort of really useful within their company. So once they have this shortlist, we move on to prioritization. And really the aim in this step is to identify the sort of next best solution, the solution that the company should engage with next. And we do this by using a set of activities that try to externalize sort of the internal gut feel or intuition of the key decision makers within the company, by looking at some of the benefits and feasibilities, because at the end of the day, these people know their company way better than we could ever. And really, our aim here isn't sort of a comprehensive business case, because in many cases the man hours required to do a comprehensive business case will likely cost more than the solutions that we're kind of advocating here. But really sort of the end goal of all of this, and the reason why we don't feel like a business case is critical, is because it's essentially a business case by trial. The aim is that a company either gets something that fully meets their needs, or they get a much better idea of what they actually need for sort of the second phase of development. Or worst case scenario, they work out that actually they thought it was a great idea, but it's actually not. But at least they haven't sunk a bunch of money into it. So at the end of this process, once the company's identified sort of this is the next thing we want to try, we move on to features. And the aim here is to try and sort of identify the minimal set of features that would be needed for this to be functional within the company. Because at the end of the day, every feature costs money, and you don't want a system that's way overcomplicated because it offers things that you don't really need. So once we've identified the set of features, we can move on to specifications. And the aim here is to try and identify some of these sort of technical requirements, pretty high level, as well as the performance characteristics that this solution would need to meet. So once we've gone through these 4 stages, we end up with a solution brief. It includes the expected benefits and anticipated challenges, as well as a set of necessary features and some technical specifications, as we've discussed. So once a company has this technical brief, they can move on to the solution development phase. And in this slide, you can see sort of our vision for how this whole process works. On the left, you have your low-cost off-the-shelf technologies, and on the right, you have this solution that you're trying to get. And in the middle, we have 2 concepts. We call them building blocks and service modules. The aim with building blocks is that you take these off-the-shelf technologies and you embed them into what we call a building block. The aim here is that these have standard interfaces, which mean that they can plug together nice and easily. Where service modules come from is that when we were developing digital solutions in the early phases of this project, we realized that there are a lot of sort of common collections of building blocks that typically go together. A good example here is data collection. A sensing system kind of looks the same regardless of what you're sensing. And so what we've done is we've embedded these common collections in what we call service modules. As we've got data collection, that's a service module. Another example is analysis, or even a user interface. So essentially, a solution ends up being a collection of these service modules, each of which is assembled from building blocks. And really sort of the benefit of this approach is that there's a standardized structure. It means that there can be less development time because every solution looks fundamentally similar. These open interfaces that are involved with these service modules mean that it's easy to integrate them with one another as well as with other pieces of technology or equipment within your facility. And really, one of the primary benefits is that it limits the potential for vendor lock-in. You're not stuck with that freelancer that you got to develop your system because they're the only one that knows how it works. Because everything looks fundamentally similar, somebody that's familiar with shoestring can come along, look at your solution, and will almost immediately have sort of an intuition of how it fits together and what it's doing. So how does a company go about getting one of these shoestring solutions? Well, really we have 3 pathways. The first is that they could get a ready-made solution. This is obviously quite standard and quite simple, but the drawback here is that you kind of get what you get. If it offers more than what you need, you're paying for functionality you don't need. If it doesn't offer what you need or everything you need, you have a bit of a compromise. The next step down is to build a tailored solution using a set of ready-made service modules. And the step below that, obviously offering maximum customization but a lot more involved, is to build your solution from the ground up using building blocks. So how does the company go about getting this? Well, in the meantime, the only way to do this is to contact us. But going forward, our intention is that if they're looking for ready-made solutions, they could contact one of our commercial partners, or they could use one of the open source shoestring solutions that will be developed by the shoestring community. If they're wanting something more tailored, that could either be done by maybe they've got some in-house talent, or they could engage local universities to embark on student projects. Step down, if they're looking for sort of the most customized option, building something from the ground up with building blocks, they could engage a freelancer or maybe a dedicated solution provider. So in this next slide, I'm just going to give you an example of what one of these solutions might look like. For example, if companies identify that they need job tracking. So obviously they have the option of going for something ready-made, but if they wanted to go the step down, just building it out of service modules, this could potentially look like a set of data collection service modules that are scanning barcodes and job cards, a system state service module that's collating all of these different events and working out the current locations of each job, and then a user interface service module that's essentially presenting this to, for example, an operations manager. To show how this goes the step down, if we look at the data collection module, this could be as simple as just a barcode scanner embedded in a building block, a Raspberry Pi, essentially a microcomputer, and then a service communication building block that handles this communication between the data collection services and the system state service, for example. To give you sort of a bit more practical example of one of our solutions, I'll now go through our data extraction from legacy panels system that we've been developing in a bit more detail. So the background here is that the company we're working with, they do etching, and they have large baths of water and chemicals that are heated. And all of this is done by an old-fashioned analog control panel. Perfectly fine, it does what they need it to, no need to replace it. However, they're wanting to get more information out for their quality control. So currently what happens is that they have a guy that walks around with a clipboard taking down readings throughout the day. However, that's obviously nowhere near real time, and it limits what they can do in terms of quality control. So what they asked us to do is have a look at this, and what we came up with was pointing a camera at the panel and pulling that information out almost visually through image processing. You can see an example here on the right of what the system looks like. And in this slide, I've got a short video sort of showing how this works. So the first step is identifying sort of what components we're looking for on this panel and isolating them. The next step is through image processing, getting the data out of them, so working out sort of what value is on the dials, whether the lights are on or off. And once you have all this information sort of in real time, you can save it and plot it, and you can get these trends for how things change throughout the day. I hope that gave you a bit more of an idea of what we're doing here at Shoestring, and if you'd like to find out more or get involved, please visit us at digitalshoestring.net. Thank you very much.